Okay, students, we are doing experiment 3. By now, hopefully, you have watched the video on the procedures and you have an idea of what the experiment is like if you were doing it physically yourself. What I want to do now is I want to walk us through a sample set of calculations with a sample set of data. I recommend that you get your unknown data sheet and have it at hand, and maybe perhaps you can go along with what I'm doing, and as I go through you can pause the video at the appropriate times so you can do the calculations with your data. Alright, let's go on. This is the chemical reaction that we're carrying out. Of course, you saw it before in our introduction. We are reacting a mixture of calcium oxide and calcium carbonate with sulfuric acid, and because of the heat we are eliminating all other products plus any residual sulfuric acid, so that all we have left is the calcium sulfate product. So our strategy is we start with an unknown, and of course we said this is a mixture, it's not a pure substance. We're going to carry out the reaction and then we're going to find out how much product. Using the methods that I'm going to explain to you, you will find out based on how much product, you will find out what is the percent composition of your mixture. I know at this point it sounds like how are you going to do that? But one thing should be obvious. If I'm relating product with reactants, there's a magic word that should come out, and that is stoichiometry. And since we are measuring things in grams, but the chemical equation is in moles, we need to exchange currencies, right? So one thing I would say is think ahead. Let's think ahead. We're going to need molar masses here. What are the molar masses of our various components here? So we have 3 of them. We have calcium oxide, we have calcium carbonate, and we have the product, calcium sulfate. So I think one thing you want to do right away is calculate what are the molar masses of these compounds. So calcium oxide is 56.08 grams per mole. Calcium carbonate is 100.09 grams per mole. So roughly a little bit less than double calcium oxide. And calcium sulfate is 136.15 grams per mole. So we would like to use those later on, so please have those handy so we don't have to recalculate them every single time. All right? Okay, let's move on. Okay, what I have here is a sample data set from a former student of mine, Steve Rogers. Very patriotic guy. I heard he joined the armed services. He was kind of small, but later on he kind of bulked up. I'm not sure what happened to him, but I do remember him being very, very patriotic. Anyway, what I have here is I only have one of his trials set of data. I didn't have the rest, but I did have the final result here. Remember that when you do these things, you're only required to display your primary data and then your calculations only for one trial. So I'm missing that, but I know that their result was 63.45 here. I'm going to show you using the data from trial 1 how Steve would have arrived at the percent of calcium oxide in this mixture. Notice that the data, well, you can't tell here because of the colors, the data is collected in ink. If there are any mistakes, you can see we're not try to blot it out or anything like that. You just run a line through the incorrect data and then fix it right next to it. All right? So this is the data. Now you should have a separate piece of paper for your calculations. And in order to track the calculations, notice that we have numbered every line here on the table so we can make reference to it in our calculations. So the first thing we want to do is you can see we're looking at lines 3 and 4. Steve did 2 rounds of the chemical reaction and didn't do the third one. The reason that would have happened was because he must have arrived at what we call heating to constant mass. So I'm going to move over here to our calculations page, and that should be on a separate piece of paper. Normally, we do these in pencil because if we make mistakes, we want to erase them and keep the form looking kind of neat. Because of the camera here, I had to do it in markers so you can see it a lot better. So I'm going to take an exception to that guideline of doing it in pencil. So the first thing we're going to do is test for constant mass. The idea is that two consecutive measurements should not vary by more than 5 milligrams. In this case, we want to look at the difference between 3 and 4. So I'm going to come in here and say, what is the absolute value of the difference between items 3 and 4? And is that less than 5 milligrams? Now, some of you might get thrown off because, of course, the balance doesn't read milligrams, it reads grams. So you have to remember that milligrams are the third decimal place in a digital display of grams, all right? So we have here, this would have been 36.6174 minus 36.6129, right? And I mean, I can do the calculation here if you want. Let's do it here. 36.6174 minus 36.6129, and that gives us 4.5 times 10 to the negative 3, which is 4.5 milligrams, right? So that means that we are okay. So the reason why Steve did not pursue a third round of reaction was because we had already heated to constant mass. Remember, heating to constant mass is a technique that is used to try to make sure that we have carried the chemical reaction all the way to completion. So now it's time to find out what are some of the numbers here. The first item we need to find is what was the actual mass of our sample. So this is item number 6. Okay, so this is our mass of our sample. Notice that I keep the calculations page somewhat organized. It's not meant to be scratch paper. It should be something that an outside reader can come in and figure out, okay, this is what they did for this part here. So essentially that would be, remember that we measured the sample already in the crucible. So the difference between those two items, 2 minus 1, that should be the mass of just the sample. So we have 36.4232 minus, see if I can fit this in here. I'm going to roll it over a little bit here. Okay, there you go. 36.2309, and that gives me a result of 0.1923. That's the number of grams. Remember that, excuse me, remember that we were told to try to shoot for about 0.2 grams. So again, it doesn't have to be exactly 0.2000 grams. We're close. So this is what we're going to write here. We're going to copy this number over here. So go ahead and with your data, find out what was the initial mass of your sample. I'm going to give you a few moments to do that. And if you want, you can go ahead and calculate it for your second trial. You don't have to show the calculations for the second trial. You only have to show one set, because the calculations are pretty much repetitive. Okay, let's look at our next item here. The next item is, what was the mass of calcium sulfate? Remember, that's the product of the chemical reaction. And this is item number 7. So mass of CaSO4. All right. And again, that should be, we're going to choose of the final masses here, the higher one according to our procedures. It says, once you've heated to constant mass, pick the higher one as your final mass. So we're going to use, therefore, item number 3 here, which is bigger, minus the crucible. And let's see how much we got here. So we have item number 3 is 36.6174 minus number 1, 36.2309. And I believe that ends up in 0.3865 grams. Okay, so go ahead and use your data to calculate your mass of product. I'm going to copy it over here. Again, remember that I am using a marker here just for your benefit so you can see it better on the video. But remember that this is not normally what we do. You would be doing it in pencil. And of course, in your case, since you're receiving your data sheet in a Word format, you can probably just fill it in, and that's fine for this exercise. Another question is, how do I use these two pieces of data, as simple as they seem, to find out what was the composition of my original mixture? Let me walk you through an intellectual exercise here. In other words, we're going to go through an imaginary scenario here to show you how this works, okay? So let's go back to our reaction. Okay, again, here is our chemical reaction. And we said that the sample mixture in Steve's data weighted 0.1923 grams. Let's ask this hypothetical question. What if this had been pure calcium oxide? In other words, that it wasn't a mixture. What if it had been just pure 100% calcium oxide? What would be the theoretical yield in that case? Well, we know how to do this, right? We have stoichiometry. So we would say that in this case, we would have 0.1923 grams, but this would be calcium oxide only, right? So to find the theoretical yield, I had to convert that into moles. And we had already said that 1 mole of calcium oxide was, right? We calculated that ahead of time, 56.08 grams of calcium oxide. So now I am in the currency of the chemical equation, which is moles. And according to the balanced chemical equation, 1 mole of calcium oxide gives me 1 mole of product. So I'm going to get 1 mole of calcium sulfate for every mole of calcium oxide. And that eliminates, remember, this is just a scenario. It's an imaginary scenario. Okay, this is not what we have. I'm assuming what would happen if this had been pure calcium oxide. It's a good review of how to do these kinds of calculations. And then we said that 1 mole of calcium oxide is 136.15 grams of calcium sulfate for every mole of calcium sulfate. Okay, sorry for the small writing. I hope you can still see that. And that will cancel out the moles of calcium sulfate. So let's see what that would be. Let's put it in our calculator. And we get a total of, let's see, this would be 0.4668 grams of calcium sulfate. This would be our theoretical yield if my substance, my sample, had been pure calcium oxide. Okay? Now, let's ask the other question. What if it had been pure calcium carbonate? I just want you to see what are the boundaries within which we're working here. So same thing, except that now we're assuming that the 0.1923 grams were calcium carbonate, right? We're going to go through the same procedure here. Everything is going to be the same except that, of course, the molar mass of calcium carbonate is different. So this will be 100.09 grams of calcium carbonate. And that cancels those out. And the stoichiometry of this reaction is the same. You get 1 mole of product for every mole of calcium carbonate. Okay, that cancels out. And now we put in again the molar mass of the calcium sulfate, 136.15 grams of calcium sulfate for 1 mole of calcium sulfate, and that'll cancel out here. And we put that into our calculator, and the result we get is 0.2616 grams. This would be the theoretical yield under the scenario if we had only calcium carbonate. Notice that it's less because calcium carbonate is heavier, so when you divide here, you're dividing roughly about, almost twice the molar mass of calcium oxide. What was the actual yield that we obtained? What was the actual yield? Well, again, you go back to the beginning of this video, and we find that it was 0.3865 grams. So notice that because my sample was a mixture, the product that I got was somewhere in between the maximum and the minimum yields if the mixture had been either 100% calcium oxide or, let's say, 0% calcium oxide or 100% calcium carbonate. Do you understand? So what it tells us is that we can expect that for a mixture, the actual yield you're going to get is somewhere in between the minimum and maximum, and that minimum and maximum, right, are going to be set by whatever the starting material was if it had been pure. So that means that my actual yield is going to be proportional to the ratio of these things. In other words, it's going to be somewhere in between these two values according to which of these two components was present in more abundance. So let's go ahead and do something here. Let's make some, let's set up some variables. Let's say that X is going to be the grams of calcium oxide in my mixture, and Y is going to be the grams of calcium carbonate. So that means that whatever I started with is going to be the sum of those. So X plus Y is going to be, let's call it, I'm going to use a capital M, and this is going to be M of my sample. All right. In this case, it was 0.1923 grams, but of course, in your case, it might be a different number. And then let's say that your yield is going to be proportional to each of these, right? Now remember, we don't know what these are, but we know that the yield will be, the total yield will be the yield from calcium oxide plus the yield from calcium carbonate, and that's going to give us the mass of product. In other words, the final amount that we got was a result of whatever the calcium oxide produced plus whatever the calcium carbonate produced. Of course, we're making a big assumption. We're assuming that these two react independently of each other, that they don't get in each other's way. That's an assumption we're going to have to live with for now. All right. Now, what would be the yield from calcium carbonate? Well, if we look at this thing we did over here, right? I'm going to bring it over here. And you can see that essentially it was, however many grams there were here. So that's X, right? That's the grams of calcium carbonate. And everything else here was ratios. So what we're left with is 136.15 divided by 56.08. And everything else is units. I'm not writing them now because I know they're going to cancel out. And then for Y, it would be same thing here. Let's say whatever the grams of calcium carbonate, and then it would be times 136.15 divided this time by 100.09. And that equals the mass of our product. How is that going to help me? Well, as we will see, what we can build with this is we can take this equation sorry, let me make sure that I showed you how this came about. So I took this thing here and I put it in there. So essentially what we're saying is that I have this equation in X and Y and this equation in X and Y. Whenever you have two variables, if you have two equations in those two variables, you can play algebra and you can adjust so that you can solve for one of them at a time. Let's refresh our memories about that, okay? So here we go. Let's say that I have two equations in X and Y, all right? mx plus y equals A, x plus ny equals B. In this case, we know the values of m, n, and then A and B. These are just numbers. How can I adjust this? Well, what I want to do is I want to create a system of equations where I can eliminate one of the variables at a time. So let's say that I take this guy here, all right, and I multiply this times n. Now remember, if I have an equation and if I multiply every single item in that equation by the same factor, I get another equation. So what I'm going to get here is going to be mnx plus ny equals na. And I have the other equation, x plus ny equals b. Right? You guys remember this from algebra, right? So what if I take this equation and I subtract now this new equation? Okay. So I took that out. So now I have mnx minus x, so that would be mn minus 1 times x. Notice that ny's cancel out, and so I have na minus b. Notice that now I have m, I have n, I have a, I have b. I know what these numbers are, so what I can do now is I can solve for x. I'm hoping you guys remember how to do that from algebra. And once I have a value of x, I can plug it back into any one of these equations, and I can solve for y. Okay? So that I can then solve for y. So essentially what we did in our approach is we built a couple of equations, right? One is in terms of the initial mass, one is in terms of the mass of product, and we're going to use those to solve for x and then for y. Okay, we are back to our data sheet here from my former student Steve. Our next step is to find out what is the mass of calcium oxide. We have the initial mass of sample and the final mass of product. So let's go back to our calculations page. And just like I illustrated in the previous section, let's build a set of equations here. So we're going to say that X is the grams of calcium oxide and Y is the grams of calcium carbonate. And we know that X plus Y, the total sum should be this value here, the mass of sample, right? So it should be item number 6, which was 0.1923. Now, what would be the yield of this reaction? Well, again, we assume that each one of the components produces a certain amount of product. In other words, contributes to the total amount of product based on the proportion of it. So we would say that the X, and we had already built this equation before, go back and look at it, times 136.15 divided by 56.08 plus Y times 136.15 divided by 100.09 should give you the final number here, 7, which in our case was 0.3865. Right? And remember, where did we get these? Well, we got them when we analyze what would have been the particular yields in this exercise we did before, right? We said, well, this is what the yield is for calcium, oxide. There it is. And this is what the yield is for calcium carbonate. And all of that should total to combine to give me the final mass of product. Okay, hope you remember how we did that. Let's go ahead and we can solve these fractions here. And let's go ahead and write this in a more manageable kind of format here. Okay, so we have 136.15 divided by 56.08, so that should be 2.4278. Remember, at this point, I am carrying these. I'm writing these numbers here. They may not have the correct sig fix, but the reason is I am carrying these in my calculator, all right? And because my masses are typically done to 4 decimals, I'm going to keep them in there. Again, this is all temporary. And then 136.15 divided by 100.09 is 1.3603y, and this equals 0.3865. Okay, again, this is that number there, and this is that number there. I just divided those fractions. I have another equation that says that x plus y equals 0.1923. So what I need then is I need to make this equation into one that will allow me to eliminate either x or y so that I can solve for only one variable. So let's do y. So what I'm going to do is I'm going to take this equation here, multiply times 1.3603. All right? So again, let's write this one again here. 2.4278x plus 1.3603y equals 0.3865. And now down here, I'm going to have 1.3603x plus 1.3603y. And then, since I multiplied 0.193 times that, I'm going to get 0.1249. All right, so this number is coming from multiplying these two here. Okay, so now I have two equations. I have equation A and I have equation B. And what I'm going to do is I'm going to subtract A minus B. So A minus B, that minus that is 1.0675x. Of course, the y's are going to cancel out. And 0.3865 minus 0.1249. Is that correct? I may have had this wrong. Hold on a second. Let me check this again. I may have had this wrong. Let me calculate it. I think I got ahead of myself. Sorry. Let's check it out. Let's do this multiplication. 0.1923 times 1.3603 equals, sorry, I had this wrong here. This should have been 0.2616. Yes. And now when I subtract those, that's when I get 0.1249. Sorry about that. That was my mistake. I got ahead of myself. And again, if you had done this in pencil, you would have erased that and corrected it so it doesn't look as messy as the one I have here. I'm going to give you a few seconds to look at that. This is very important that you understand the math here. All right? Very important. Okay, let's make sure you get it. If you need to pause the video and work on your numbers with your data, go ahead and do that. Okay, until you get the right value here. Okay, so now I have an equation in x. So I can solve this, divide by 1.0675 on both sides, and I get 0.1170 grams of calcium oxide. All right, I'm ready to copy that to my data sheet. See if I can find it. Here we go. So we have 0.1170. That is the grams of calcium oxide. And of course, to find the mass of calcium carbonate, item number 9, well, by conservation of mass, if we started out with a sample 6 and we had out of that 0.1170 grams, so we subtract the number in 8, so we have 0.1923 minus 0.1170, and that equals to 0.0753 grams. That is the mass of calcium carbonate. Let's go ahead and put that in our sheet here. All right, so we have here 0.0753, and that was the mass of our calcium carbonate. Ultimately, we want to find out what is the percent of calcium oxide. So let's go back to our calculations page. I'm going to scroll it a little bit higher now. And this is going to be item number 10, percent of calcium oxide. So that would be how many grams of calcium oxide we have, which was item number 6, divided by how many total grams we had, which was item number 6, times 100%, which is just to roll the decimal period. So let's go ahead and find out what that is. So we had 0.1170 grams in a total 0.1923 times 100%. Let's see what that comes up to be. 0.1170 divided by 0.1923 times 100, and that gives me 60.8424, but I have 4 sig figs here, so that means that I have to round that to 4 sig figs, 60.84%. Of course, if they ask me, I would, subtract that from 100 to find the percent of calcium carbonate, but they're not asking me for that. So let's go ahead and write that over here, 60.84. Notice that in the second trial, although I don't have the data here, Steve had obtained a percentage of 63.45. This is the same initial mixture, unknown number 4. So let's find out what is the average. I think you should all be able to calculate that, right? So let's do item number 11, the average. So that's the sum of the items divided by the number of items. So we have 60.84 plus 63.45 45. Oops, sorry, I kind of like made it too big here. Divided by 2. And that equals, again, since 2 is an exact count, the prevalent rule here is you have decimals. So you're going to end up with 2 decimals in here. And so I believe that comes up to be, let's see what it is. 60.84 plus 63.45 divided by 2 equals 62.145, but we have to kind of round it to 2 decimals. So 62.15%. Let's go ahead and put that over here. 62.15%. Now, whenever you do these kinds of experiments, remember that one important factor is how reproducible are they? How do we get the actual certainty of how good the data was, right? First of all, when Steve turns in a report like this, when you turn in a report, I have my table where it tells me what the actual result should have been, right? So I'm going to compare your result with what it should have been, and I will grade you on the basis of how accurate your determination was. Of course, in your case, you are all being given the actual data, so presumably your results should be accurate unless you made mistakes. But I'd like to see how good are these numbers, how reproducible are they. For that, I'm going to do the percent difference. I'm going to bring another paper here so I can do it big enough. So this will be item number 12. What is the percent difference? The percent difference is a way of assessing how reproducible my results were. In other words, how precise my data was. And remember that the formula here is you're going to do the absolute value of the difference between 2 trials, trial 1 minus trial 2, divided by the average, and again times 100%. So our values were absolute value of 60.84 minus 63.45. Our average we found was 62.15. All of that times 100%. Notice that these are percentages. This is a percent also. So we are doing that. So let's go ahead and remember how we do sig fix in this case, right? So let's go ahead and do that. So 60.84 minus 63.45. Of course, it comes out negative, but we want the absolute value. Okay, that value has 2 decimal places as it should be because that operation is a subtraction. Now, when we divide in the next step, the denominator here has 4 sig figs. This one is only carrying 3. So that means that we have to round to 3 sig figs. So let's divide this by 62.15 and multiply that whole thing by 100. And we get 4.1999 whatever. But we have to round it to only 3 sig figs. So this would be 4.20%. And now we come back here to our data sheet and we get 4.20%. And if you want, you can probably put the units here just to remind people that these are percentages. I didn't have to do that here because the table already had the units here in grams, so it did over here. So that way I don't take up space with a G in there that might be confused for a number like a 9 or something like that. Okay, so this is the activity here. So what you'll do is you want to do this with your numbers. Please review, check your math. I know some of you are rusty with systems of equations, but hopefully you can get it. If you need help, please either contact me or, you can also contact the free tutoring service that the school provides. So that is it. Our next stage is for you to wrap up your data sheet here. And there is another page that has some post-lab questions. You are required to complete those and turn them in also as part of your lab report. Thank you so much.